All right, so I've got an event I want to go to at 7. It's a discussion by a panel of doctors on how lessons from 1918, the Spanish flu pandemic can apply to the current pandemic. But before that, I've got a full 50 minutes, and what better thing to do than continue practicing for this exam? So I'm going to share my screen. Last video, we left off doing some verification checks. So this video will complete those checks, and then we'll move on to understanding internal BGP peering sessions. And that will require a different lab topology. So there will need to be a lot of changes. And I can probably do that on the video. But all right, so let's start with show BGP group on router E. Oh, okay. So actually last video where we stopped is my BGP connections are not coming up. So we were actually troubleshooting that. So got quite a bit more work to do. Oh, yep. And we saw that due to this special setup, it being a part of a routing, a logical system, and by nature of having DLCs and frame relay, you can assign network addresses to the INET6 interface, but without all that special configuration, it's got to be a host address. Cannot sign address 0 on subnet, so it can't be a network address. It's got to be a host address. So I will change that. I'm kind of curious if that was said to be configured on router E as well. Yeah, it was. Okay, so I'll make router E.1 for all of them, and then I'll make router A .2. I'm just surprised. It looks like you can do that if you include this EUI-64 keyword. Let me do a run show system rollback, or let me do a rollback 0 and exit show system rollback compare 1.0. Okay. So it commits with a network address. Yeah, so you actually can assign a network address even if you don't have DLCs or frame relay or any of that extra stuff, as long as you include this keyword here. Then it will build a link local address, and then just assign this prefix to it. So if I do a show interface first, pipe match GE dash. So here's the beginning part I assigned to it. Oh, okay. Well, that's for the loopback address. For the address here, you can see we've got the colons here. So it's going to be a 0 because I explained in the last video, whenever you have a colon, you're abbreviating for octets that are for sections of the IPv6 address that are all zeros. And here we can see we have 4 sections because we've got 4 other sections here, and we're going to have a total of 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we can see, yep, here's what we assigned to it. And then for the rest of the address, we wanted it to be EUI-64. So last video, we figured out what that's going to be, and it's going to be here. So yep, it's got a valid host address. So I think we just need to figure out now why it's not coming up. So let's make sure that the first part, 2001 DB8, 01, 2001 DB801. Yep, that looks right. So let's see if they're pingable. I'm going to try to ping this from router A. And I can ping. So let's figure out why, even though I can ping, I can't form a BGP neighborship. Yep, so it's definitely in active state. So, and it's the IPv6 peer that's in active state. So it's not like I'm looking for information that's about IPv4. Yep, the neighbor looks right. I guess one thing that's surprising me is that this would like is this accurate? I wonder if that neighbor address is accurate. And it looks like no, it's not accurate because perfect. Okay, so I understand what's going on. Since it's EUI dash 64, so extended unique identifier, since it's going to be that. So it's going to be a unique identifier based on the hardware of your device. So the lab hardware here that they're using here is going to be different than what I'm using here. So my MAC addresses are all going to be different. So if they're saying that I need to, in my lab, set up a neighbor to this address, well, all they're saying is this address is what you specified on, in this case, yeah, router E, the first portion of it, but then this next portion is going to be what was assigned through EUI-64. But I'm surprised there's no FFFE in this neighbor address. That's something that, but in any case, that's the issue I'm having, is that the neighbor IP address is not correct. But why is there no FFFE in, that might be worth asking, because I mean, if these are EUI-64 addresses, because it's the neighbor address, and you can see we don't configure any other kind of address, just have those EUI-64 ones. Oh, I guess we have loopback addresses. I think that's the loopback address. Well, but no, it's not though, because we can see router E, the loopback address is going to be 2001 DB801. Oh wait, no. 2001 DB85. That's the loopback address on D. So on device E. So if you're on device D, your neighbor is either going to be that loopback address, which we can see is clearly not, or it's going to be the port to D. So this port here. But we can see that port is going to be that EUI-64 address is what's configured on it. And that will have FFFE. So clearly there's something very wrong with this documentation. I think it's definitely worth a downvote, even though it's using DALSIs and it's using peer units and encapsulation frame rate, encapsulation frame relay, that sort of thing, you know. But I don't think, I mean, that's all at layer 2, so it's all kind of going to be, I think, transparent to the IP addressing schemes. And the IP addressing schemes, if they're created with EUI-64, you can see they're going to have FFFE in them. I mean, that we just read the RFC in the last video. Like, that's just a fact of EUI-64. So yeah, I think it's worth a downvote. Sorry, Juniper folks, it's not a proud moment for me, but it's a moment that I think is definitely going to be important. And I'll just say, why do the neighbor statements in the BGP configuration, why do the neighbor statements in the BGP configuration not contain FFFE in the IPv6 address? So why do the neighbor statements in the BGP configuration not contain FFFE in the IPv6 address? The addresses configured on each of these devices are done so via EUI-64. Yeah, so why do the neighbor statements in the BGP configuration not contain FFFE in the IPv6 address? I'd say addresses because there's multiple neighbor statements. The addresses configured on each of these devices are done so via EUI-64. So that's kind of I think a pretty glaring mistake in the documentation, like for these neighbor statements not to have, and if you know a little bit about IPv6, but you're not an expert, you might say, oh, well, maybe it's the link local address, but link local addresses start with I think FFEE, and this is something to verify. Yeah. So link local addresses. I need something more simple. Yeah, okay, FE80, there we go. I knew it would jump out to me immediately once I saw it, even though I don't see where it's, here we go. A link local address is an IPv6 unicast address that can be automatically configured on any interface using the link local prefix, FE80::/10. So right here, here's all 10 bits. So, that argument is out of the water. Oh, well, maybe they want you to connect up to the link local address. Well, maybe they do, but then there's still a mistake in the documentation because this is not the prefix of a link local address. In fact, it's the prefix of a global address. Yeah, so all the way up until /32 is reserved as a particular kind of, well, let's go and read the doc. So there's nothing good in here. Just wanted to explain that it's what kind of an address it is. Okay, so this is a documentation prefix. So it's used in documentation, just for documentation. So that's good. Let's look at the global or whatever I was thinking of. So there's unique locals. Well, guess I don't know what I was thinking of with the term global. You know, as I said, IPv6 is a bit rusty for me by now. So there's a link local and there's a global address. So that's what I was thinking of. It's just a global address is something that's not a link local address. So it's not like it's going to have its special prefix. It's just going to have any prefix that's not reserved for specific usage. But the link local is going to have FE80/10, and then the 2001 DB8/32, which I thought was what I was thinking of as a special, like I knew it was a special kind of address, and I thought it was like a global something address, but it's just for documentation. Global addresses are just addresses that aren't link local addresses that don't start in FE80, and a global address can be anything that's not already reserved for another use, such as this 2001 DB8 or the FE80 or any of these. All right, so moving on. So we know what the problem is. It's those neighbor statements, and we submitted the downvote for that. So let's go ahead and fix those up. So we got to fix it up on both sides. Let's start with E, because that's where the most amount of fixing is going to have to happen. All right, so yeah, none of these have FFFE in them. And even if they did, these are going to be MAC addresses or you know, modified MAC addresses that are unique to the equipment they're using here and that have nothing to do with the equipment I'm using. So if I want to correct these, I'm going to have to go through and take a look at what actually got configured through the show interfaces terse command. So this is what I got to use. So I will use it. And I'm just going to clear off all the neighbors. Oops, can I do a star? I just want to delete all the neighbors. Let's see here. 1, 2, 3, 4, show pipe display sets. There we go. So now I'll configure the new one to router A. All right, now it's time to configure the one to router B. And of course, I don't know what it is. It's nowhere in the documentation or anything because it was generated using extended unique identifier -64. Oops, and I don't need to be in configure mode. I just need to figure out what address I need to use for the neighbor statement on router E. Oh, okay. And here's the good old-fashioned GNS bug where it rolls back your last commit just randomly sometimes. So I had thought about this, but unfortunately I did not do it. I had thought about making a superfluous commit just so that if it rolled back my last commit, it would roll back one that didn't matter if it rolled back. So like leaving a description saying a GNS bug, and then whenever I go up, I do show configuration pipe match GNS 3 bug, and then if it doesn't show up, I'm good. If it shows up, I can start off by rolling it back, and then every time I finish the lab, just make that one last commit. But that's kind of a lot to do. I mean, if you got like 10 routers opening each one and typing in GNS bug and committing can take like 5 minutes. All right. Okay, so it just looks like I never removed the addresses. I only applied configuration. I never removed it. So it's not the GNS bug, thankfully. Yeah, I think typically that bug only occurs if the program if GNS is closed and then reopened. And even then, I think it only occurs if it's closed for a long time. Like I haven't really seen it occur when it's closed for when I just restart it. Like for instance, if I'm getting an issue with Wireshark not opening, I haven't seen that issue come up where it rolls back the last commit. I've only seen that happen if GNS3 has been closed for like overnight or multiple hours or something. All right, so neighbor statements. Here's delete neighbor. Whoops, and I have to specify it. I'll set neighbor. And it's going to be, oh, right. I wanted to do it on, I just wanted to do, but that's okay. I mean, I can do it on both sides. It'll save me going back and doing it. Nothing wrong with that. Oh, but the problem is, oh, okay. I had to go into configuration mode because I didn't apply the configuration correctly. And even now, I seem to be having some trouble. Oh, it looks like it's prioritizing INET over INET6. If you have both, it'll pick INET instead of INET6. So let's get rid of INET altogether and just have INET6. Okay, now everything is good. Perfect. So on to the next one. I think I will go back to A just because I don't want to have to remember when I'm done with the other two. All right, so this neighbor statement's got to go because you can see it's clearly not a EUI extended unique identifier. Extended unique identifier. It's clearly not that kind of address. So there's clearly some sort of issue in this documentation where they're telling you to use extended unique identifiers, but the neighbor statements, either they didn't properly tell you to put this on the loopback interface, or it's just a flat out mistake. But submitted a downvote, so hopefully they can get that reviewed. And I think right now, yep, I just need to set that neighbor statement. So delete neighbor, delete the one that's on there, and then set neighbor. Let's see what the address is. It's going to be this first one up here. So I'll just run this again. Perfect. There we go. So now I should have two BGP established by now. Looks like I don't have them. Oh, did I not commit yet? Okay, yeah, I didn't commit this side yet. I've only been committing on this side, but we will be done soon. All right, configure private, edit protocols, BGP, group external peers, show pipe display set relative. That's interesting. It looks like there's two on letter C. Oh, and it looks like I've got the same issues. All right. Just got to get rid of these two neighbors. And then set the neighbor to router E, port 2. There we go, and commit. All right, and now C, and now D, and that's the last one, thankfully. Oh, it looks like D didn't even get the configuration it needed for IPv6. So I can take care of that right now. Delete interface G000.0, family INET. And now, of course, delete that external peer as well. Okay, but now I'm going to need to set the address on here. So I'll do the edit interface. Family INET 6, set address. And then, of course, it's going to be just the prefix with the EUI-64. It's kind of a nice shortcut you can take because IPv6 addresses can get pretty long, and just using the EUI-64 extended unique identifier can really help you kind of save some keystrokes. All right, so now we got to set the neighbor, top, edit protocols, BGP, external peers, whoops, group, I always forget that, external peers. I'm going to set the neighbor, see if I was able to clear off. Yep, so set neighbor, and then got the last port here, port 3. So commit and quit. Okay, perfect. So now let's take a look at what neighbors I've got configured on here. Oh, so I've only got 2. So I need to add neighbors C and D. So I'll just open C, leave D open. And take a look at what I got here. There we go. All right, one more. Hopefully that AUI-64 extended unique identifier. Hopefully that will have successfully assigned an address by now. And it did. Okay, so this is now good to go. I'm going to start a Wireshark capture, and then we'll see what happens when in Wireshark when this goes into established. These are our neighbor advertisement messages, or sorry, neighbor solicitation. Kind of what I thought they were, but I said advertisement for some reason. Aha, so here's all of our BGP. If you notice, we've got, let's see here, Cincinnati ACK. That's interesting. I don't see the second Cincinnati ACK that we would need an IPv4 to prevent that race condition. So maybe it's just not a problem in IPv6. But we've got a good old-fashioned open keep alive update. And if there were an error, we get a notification. So that's all looking good. So let's make sure all the other links didn't have any issues. Oh, well, it looks like we got some issues on router D and router E. So, oh, sorry, router D and router C. So let's see router C. We can stop the capture. Well, it'll probably just stop on its own due to the bug. So we'll just leave it running. But we need to check why. Oh, okay. And we can already see there's more issues with IP addressing on this. So let's look at the documentation. We're on router C. So router C's loopback is going to be .3. So this extra .4 I'm going to take off of there. Don't think that'll make a difference though, but definitely want the addressing to be correct. So everything else looks pretty good. What about the autonomous system? Oh, so here's a problem too. The autonomous system on router C is going to be 22, not 79. All right. So that looks good. Here is going to be 17. So hopefully this one will come up now. We're going to see it go into active connect, open sent, open confirmed, established. And if I shut down one side of the link, it would go into idle. So you saw it go directly from active to established, so really fast connection. Didn't even go into connect, open sent, or open confirmed. All right, so we fixed the issue with C. Now let's fix D. So D looks like it's got the right autonomous system. Looks like it's missing its loopback address, but that's really not going to matter for anything. But just for the sake of completeness, I will make sure it's configured as close to the documentation as I can without, of course, overcoming my limitations with frame relay and logical systems. All right, so next, ::4. Yep, ::4, yep, that looks good. Maybe verify the neighbor. So autonomous system looks right, the remote AS looks right, so perhaps there's something off with the neighbor. So let's do a commit and quit first, quick here, and then let's check that this neighbor is actually configured on router E. So show configuration, pipe display set, pipe match that address. And sure enough, that address is actually not on router E. So let's see what address is configured going to router D. So, oh, okay. So it's trying to form a session with peer AS22. So I think this would be interesting to get a Wireshark capture of, because it's sending out that three-way handshake, but it's trying to, it thinks it's in a different autonomous system. It's trying to treat this as if it were in AS22 and not AS17. Sorry, AS72, I believe. Whatever it is, it's 79. 17 is the AS that router E belongs into. D is in 79, and then the other three are in 22. But if I don't include that extra peer AS 79 here, it thinks it's in 22. But we'll see, hopefully, some kind of error messages. So I'm going to go ahead and delete this. And now commit. And then I'm going to roll back one, commit. And guess what I'm hoping to see, which I might not. I'm hoping to see some traffic over there, but looks like that's not the case. Let's look at the, oh, okay, yeah, this is what I was thinking I would see. So show Bgp Summary. Looks like it just took it a while to go through. So it's inactive. And yep, sure enough, we've got SYN, SYNAC, ACK. So it was actually able to complete the three-way. This is actually really interesting. I'm really glad that I decided to capture this. And you can see there's a notification message, which we learned in an earlier video is how errors are reported. So obviously there's going to be an error because the autonomous systems don't match, but I actually am a little bit surprised that it was able to have a three-way handshake, but at the same time, I'm not that surprised because a TCP connection, I don't think is aware of an autonomous system. So it's just, you wouldn't have any issues with the TCP connection if you had the wrong autonomous system. You had issues with the actual BGP protocol. But we can see perfect SYN. It's initiated from :4. So I guess I'm not even sure which one this is. I'd have to have a better sense of those addresses to know. And unfortunately, there's no other information I can use. So yeah, nothing really to see here. Here's all the flags you can have for TCP. You can have reserved, You can have notes. You can have congestion window reduced, or CWR. You can have ECN echo. You can have urgent, acknowledgement, push, reset, SYN, which is of course the one we've got on here, or FIN. All right, and let me actually pull up the bits window as well, because that's interesting to look at, I think. And let's look at that SYN bit and see actually where it is. So it's right here. All right, now let's look at the SYN ACK. So same SYN bit is going to be on that was in the last packet, but now we're going to have an additional ACK bit, and we can see here's ACK acknowledgement. So we're going to have in this packet ACK acknowledgement and SYN. So 1, 1 there like that. And now we're just going to have the ACK. So you can see right there, just the ACK. All right, so now we got our BGP open message. I can move that down again. We're going to have more TCP because it rides on TCP, so that's always going to be there. And you can see, let's see here. Yep, MyAS17. Over there highlighted. I'm always kind of interested just to dive in, but I don't think there's anything relevant in there. Really what we're trying to see is, here we go, MyAS79. So, I mean, that will work, I think. Let's see what this notification message says. Open message error, bad BGP identifier. So let's see what the BGP identifiers are. Oh, okay. 0.0.0.0. And this one has 172.17.5.5. So that's interesting. I actually thought the issue was that I didn't specify the autonomous system correctly, and I'm surprised that's not the issue, but it looks like the way that is being realized is because the BGP identifier isn't able to. So I wonder if I fix that mistake, if I'll still have another mistake with it not being able to find the correct autonomous system. Because right now it's looking for autonomous system 22, which all these are assigned to, but this one's on its own 79, and this one's on 17. But it looks like there's a greater issue, and that's one of these don't have a proper routing ID set up. Then I have a feeling it's router D. So yep, you can see there's no configuration on the device for the router ID. Oops, and if I exit out of here, yep, I've got a router ID 172.16.5.5. So let's see what the documentation says to use. Okay, .4.4. So now I think there will still be an issue. So I'm going to want to make sure that I have capturing going, that GNS3 bug didn't go through. So I'm going to set routing options. Oops. Perfect. And now before I commit, I'm going to make sure I have a fresh capture. And then I will commit, and I'm expecting to see a different kind of notification message now. I'm expecting to see some kind of like neighbor solicitation or something like that. So I kind of want to wait for that just to make sure that there's nothing wrong with the capture. I could probably just hit it. All right, so that's interesting. There's really nothing showing up right now. It looks like it's still inactive, which is what I expected it to be because the AS wasn't correct on there. Let's go ahead and ping and make sure that the capture is still running. So yep, the capture is still running. It's just interesting that I put the router ID on there now, but there's no messages that there were before, even though it is inactive. So I would expect there to be SYN messages sent out. I'm just not seeing any. Oh, now I've got some. Okay. So yeah, here we go. So here's that notification message again, which I was expecting because, yep, bad peer AS. There we go, perfect. So we can see we've got SYNAC X. So we did get that race condition now that we got by not having the passive command. We can see each device, 2 different source addresses, sent out that initial SYN, and then each responded back, but one of them had to say, "Oops, oh no, sorry, I'm the one who," one of them had to do this. Well, it looks like they both did the FinFinac act because they both had that error with it where it was the wrong AS, so you couldn't even get to that message that we saw before. But once I fix this, we'll see that message, so that'll be a good reminder. But for here, the only thing to really take note of is this 4th kind of BGP message, aside from an open, a keep alive, or an update, the notification message. And we can see here it was part of the open message because it actually failed to establish opening BGP, so it just included you couldn't add a notification as its own message after it was open because opening is what failed, so it just appended it on there. And bad peer AS, and that's going to occur right, oops, yeah, right here, the 2. Here's the marker, so it's marking that it's showing that there's, well, I mean, that's all we needed to see, so I will fix that error and then restart the capture, and hopefully we'll see that race condition again. And we'll see what the official error is for that. I've got about 5 minutes, less than that, because I want to make sure I don't miss any of the event. I want to see at 10, so I might need to cut it early, but there'll be plenty of good content for the next video. Edit protocols, BGP group, external peers. So, oh, and this is on D. D, I don't need to make any changes. Okay, so D is run showing terse, pipe match, G dash. So 502, yep, the 1 at the bottom. So I gotta set it to peer AS 79. Perfect. And then I'll do another show. Perfect. And before I hit that commit, I'll get the Wireshark out, and we'll unfortunately still see that race condition because I didn't set up the passive command. but we'll see what that is officially called in Wireshark. I actually need a refresher on that. I forgot what it is reported as. But I believe it's going to show up as part of a notification message. We'll definitely see. And unfortunately, it looks like it's going to take some time for that to pop up, kind of how it did before. But let's see if BGP is now established. Oh, and there it is. BGP is now established for all my links. So let's see if there's a race condition. Nope. Looks like that's not so much of an issue in IPv6. It's kind of only an IPv4 thing. One thing that might be interesting to look at. It's interesting that there's an update message too. Unreach. So because there's nothing advertised into or redistributed into BGP right now, so I'm kind of surprised there's update messages. But anyways, that would be interesting to see if I can actually include that passive keyword. So set neighbor, and then let's go with this one. And now is that passive even an option now? It is. Okay, so that race condition is still something that can happen in IPv6, but luckily you can still use that passive keyword to prevent that. All right, so thanks for watching. I'm gonna have to cut it short so I can get to the seminar I want to attend, but lots of good content to come. Thanks for watching and stay tuned.